So we've talked a lot about the precursors to climate change. We've talked about what greenhouse gases were, we talked about the carbon cycle, we've talked about trends and who's releasing these greenhouse gases, and now we're going to talk about what is the impact of these greenhouse gases in our atmosphere, or really the addition of these greenhouse gases. Now, what this lecture is going to talk about is what we are seeing today. Although we will talk a little bit about what may happen in the future, I personally think that it's important to focus on what's happening right here and right now, because that's our strongest evidence. It's what we're currently seeing. And so that's what today is going to be divided up into, is what are the things that we're currently seeing? And it all ties back to the simple fact that greenhouse gases in our atmosphere act as a warming blanket. There's no refuting that, and it's going to have impacts on our Earth. So the first thing, and kind of the thing that's going to affect all the other effects that we're going to see, is that our average surface temperature has increased. This should make sense. We know that certain gases in our atmosphere have a heating effect because they bounce back heat towards Earth. So it only makes sense that if we have more in our atmosphere, that we're going to have a warmer atmosphere. Now, I do emphasize the word average because there are some places that are going to get colder, and there's going to be some places that have gotten warmer. We'll explore that more on the next slide, though. So what we're looking at is NOAA has been recording our world temperatures for a long time. They have sensors all over the world, and starting at about 1880, they kind of determined, or looking back, have said, okay, the data that we've had since 1880, we are confident in the values that we recorded. The way we're recording temperature back then is the same way we're recording data now. And the reason I make this distinction is we do have temperature data from before 1880, but it was measured differently. It was using different types of instruments. And so NOAA doesn't want to use that data because it might not be as accurate, or at least to the same scale as what we're looking at today. So from 1880 to 2018, NOAA has looked at the complete record of temperatures over the year and has ranked these 140 years by the warmest to the coldest. This list is the top 10, and if you look, the warmest year on record is 2016, followed by 2015. By 2017, by 2018. And you're probably seeing a trend here is that the 10 warmest years for most of you guys were all during your lifetime. We are living the warmest years now. Now this anomaly that you're seeing on the right-hand side in Celsius and Fahrenheit, what this is measuring is that if we took the average temperature between 1880 to 2018, this is how much warmer that year's temperature was. So for example, in 2016, there is an anomaly of about 1 degree Celsius. Now you may think, well, what's the big deal? It's 1 degree. Or with Fahrenheit, it's 1.7 degrees. On a typical day, that may not matter. On an average temperature, this is kind of a big deal. To put it in perspective, during the last ice age, our world temperature was 3 to 5 degrees Celsius colder than it was, what it is typically. So those small changes in temperature actually have huge ramifications when we look at our environment. Now what you may be wondering is, okay, this goes up to 2018, how's 2019 looking? So 2019, as of right now, this video is being filmed October 2019. As of right now, we are looking at second on record. Now, we still have a couple months to go, so this may change, but based on how warm it's been January all the way through October, we are looking pretty warm. Maybe not 2016 warm, but we're looking pretty close to it. So we'll know if you take my class in the future. This will be updated with 2019 on there, but that's what we're currently looking at. Now, I mentioned before that I emphasized the word average surface temperature. So the map that you're looking at here is looking at this past year of 2019 and taking a look at the average temperature during this past time period and then comparing it to the past 30 years to see where is it warmer and where is it colder based on the average of our past 30 years. And if we're looking at the brightest red, that's going to be where it's gotten a lot warmer. And you notice that the brightest red that we see on the map is in this 4 range. So while the average surface temperature may have only increased by 1 degree Celsius, some places have increased a lot more than that. Many more than that. And a lot of that, as we're seeing, is around the Arctic Circle. So places that are already cold, places that are frozen for parts of the year, have now gotten so warm that they're melting. And we'll talk about that more in a little bit. But if you notice, it's not the same throughout the world. Not everywhere is warming up 4 degrees. Remember, our average was only 1 degree. There are some places that are getting cooler. So on our map, it looks like the coldest we get is maybe in this -3.5 range, and that is in the northern central United States, so looking at the Dakotas, looking at central Canada. Some parts of our oceans, so part of the Atlantic, part of the Pacific is getting cooler. But in comparison to all the warming areas, it's really not that much. It's not evening out. It's not the amount of coldness is being counteracted by the amount of warmness. It's the amount of warmness is drowning out the amount of coldness. And so I really emphasize this because you'll see people, particularly on social media, they're like, oh, it's snowing more than usual. Global warming, what's that? Ha ha ha. They're idiots. It's not the same everywhere. And this is also why I personally try to stray away from the term global warming, because it gets a connotation that a lot of people don't understand. They think, oh, global warming, Earth's getting warmer. As a whole, it is. But try saying that to this person in North Dakota, which is getting the coldest temperatures that they've ever had. So global climate change is, I guess, a little bit more accepted or a little bit more understood than saying global warming. Now, on a test or something, if you say global warming, I know what you're talking about. But that's why you kind of hear the term global climate change a lot more than you hear global warming these days. And it's mainly because we're trying to move away from the stigma that people have with this term global warming. Now, the rest of the impacts we're going to talk about are due to the fact that our average surface temperature is increasing. So the next thing that we're going to talk about that's affected by temperature are changes in global weather patterns. So if you're going to change the temperature of our atmosphere, a lot of natural processes are going to be affected by that. One of which is moisture and precipitation. So when it is warmer, more moisture is taken out of our soil, is taken out of surface water, and evaporates into the air. And when it evaporates, you get more precipitation. Now, the way our Earth works, this is putting it super simply. If you think about where deserts are, what's happening is that the air around deserts are pretty warm. It's sucking the water out of our deserts, and then big air cells move that precipitation over to our rainforests, and then precipitates on our rainforest. So the moisture taken out of the deserts is put into the rainforest. Very, very simplified. You guys could take an earth science course and probably spend a unit talking about that. Anyway, if we increase the temperature, then what's happening is that dry areas that already get their moisture sucked out are getting more moisture sucked out because it's hotter. And if they get more moisture sucked out, that moisture has to go somewhere. And so that rainforest that's already getting a lot of rain is now getting even more rain. So that's what I mean by more drought and more rain. Places that were already dry to begin with are getting drier. Places that were already wet to get with are getting wetter. Now, the reason this matters, because you might think, oh, places are getting more rain, that's awesome. Yeah, tell that to places that are exhibiting landslides. Tell that to places that are facing flooding. More rain is not necessarily a good thing. And especially if you think about agricultural regions, there are plants that want a very certain amount of water, and that's it. They don't want any more than that. Plants can drown as well. And places that were semi-dry and they're getting even drier, so farmers are being negatively impacted by these changes in weather patterns, not just because it's warmer, but the amount of moisture, which is something plants incredibly rely on, is being affected by it. So this map is taking a look at the United States. This is looking at October 2019, and it's comparing it to the past about 120 years, saying, okay, of the past 120 years of precipitation data, looking at this October compared to all these other Octobers, are we really dry in comparison, or are we really wet in comparison? So the record driest is this gray, and the reason it's gray, it must have gotten cut off, means that it's tied. and it was tied with like 0. So if you look at Southern California, Nevada, Arizona, their record driest October was this October. It's tied for some other Octobers though. If you look at the record wettest, so looking at Mississippi, Tennessee, parts of Wisconsin, parts of Michigan, parts of New York, these places over the past 120 years, these places are experiencing the wettest October they have ever seen. And so the biggest deal is the fact that we're going to extremes. It's getting wetter, it's getting drier. The lightest colors, these are the ones that are more or less the same, either the same or slightly below or slightly above average. But it's these darker reds and these darker greens. These guys are experiencing more or less than what they've had in the past. Their farms, their industries are based around precipitation that's been prevailing forever, and now it's changing. And again, this is all just because our atmosphere is getting warmer and it's displacing that liquid. California's always been dry. They're just getting drier. The Midwest, great place to grow corn, always been wet. But now it's getting even wetter. And so this is going to have serious implications, not just here in the United States, but this is happening around the world. Related to this, so I still have it as the same number, so change in global climate, global weather patterns, is looking at hurricanes. So hurricanes form specifically in the Atlantic Ocean, and they are fueled by warm water. Well, unfortunately, when you have a warm atmosphere, it's going to warm the water. And so we're seeing that with this increased water temperature, we're also seeing an increase in how severe hurricanes are, as well as how frequent hurricanes are. Now, we've had big hurricanes in the past. I am not disputing that at all. They naturally come in cycles, but typically those cycles are very wide apart. They'll call it the 100-year storm or the 500-year storm. Yet, we're having a every-year storm. So what I chose, the 3 pictures on here are the 3 largest hurricanes we have had in the past 3 years. So earlier this year, looking at Hurricane Dorian, which landed in the Bahamas at a Category 5 and stayed over the Bahamas for over a day as a Category 5. So here's a picture of that devastation that came to the Bahamas. The year before, Hurricane Florence had a direct hit on Wilmington. As some of you might remember, I spent a couple years in Wilmington. They were completely shut down for weeks. You couldn't access the town at all because the interstates were crazy flooded. And that was just as a Category 2. And then if we look at Hurricane Harvey 3 years ago, 2 years ago, 3 seasons ago, I'll say, that hit Texas, was insane. I mean, this is their interstate, and you can see just how flooded it was and the amount of devastation that happened in that area. So instead of these happening every 10, 20, 50, 100 years, this is happening every single year. And I just chose the absolute worst hurricane of the season. There were other large hurricanes that did a lot of damage to other regions in the United States as well as in the Caribbean. So again, hurricanes very specifically, just because these types of storms are fueled by warm water. There are other types of storms, such as monsoons and tsunamis, that are more based on other things. So they're not as affected by water temperature, but it's the hurricanes we're worried about. And here in the United States, I mean, especially with us living on the East Coast, huge impact to us.